So how do you make these pulsars? Because I remember you said you can take any two stars in the galaxy and then make them as the endpoints of that detector. Can you talk about it a little bit?
Yeah. So what you can do, what you can do is you've got pulsars, and basically what you do is you observe them similar to the LIGO detector. A LIGO detector has got two arms like so, right? And so what you can do is you can do the same thing but on a galactic scale. And so you've got a line of
Right.
pulsars like this way in the vertical direction, and a line of pulsars in the horizontal direction.
Okay.
Now, let me be clear that these directions can actually be completely arbitrary, so you
Yes.
can define them however you want. Just
Exactly.
remember that they should
Right.
be perpendicular to each other, i.e., they
Right.
should form a 90-degree angle with each other. And
Mm-hmm.
basically, what you do is you use those pulsars to determine if there's a change in phase. And this change in phase could be a change in spin period, a pulsar glitch. In terms of LIGO, it uses extremely precise clocks and measuring devices to be able to detect changes in phase with different wavelengths of light. And if there is a change in phase, then that means that something passed through, and this could be like like some human activity, or it could be a gravitational wave. Um,
Mm-hmm.
so yeah, that's just one way as to how you could go about using pulsars. Obviously, there are many other ways to do so. But yeah, in terms of how pulsars actually form, I'll just quickly mention that pulsars form by supernovae. So what happens is that a really giant star, like ten times, or a dozen times more massive than our sun, it explodes in a supernovae, and that's because what happens is that the star actually collapses in on itself, and that collapse causes an immense amount of pressure, and that immense amount of pressure releases a lot of energy within the star's core, causing like a giant explosion. And so what happens is that you're left with just like a single ball, and this is the remnant of that supernovae, which can either be a pulsar or a black hole. But sometimes it's but sometimes it's pulsars, and sometimes it's black holes. Yeah. Um,
Fantastic.
yeah. Um, yeah, I'll just also quickly mention that, where just a bit of history as to how pulsar astronomy actually got started,
Mm-hmm.
because I really find this story very funny. And that is that
Mm-hmm.
pulsar astronomy actually first started in 1967, and it was started by a radio astronomer by the name of Jocelyn Bell. And at first, she thought she was seeing deliberate attempts from contact from aliens, but as we all know, it's never aliens until it's aliens. In
Right.
fact, she was so convinced that she named one of the first pulsars LGM-1, also known as Little Green Men 1. However, as later analysis showed, she had really discovered a new type of neutron star, and the search was on to find as many of them as possible. Since then, we've found like 2,657 pulsars, and that's mind-boggling. And
Yeah.
we still might find more. Pulsar astronomy is a really active field of astronomy, filled with mysteries and discoveries. Um, yeah, and in fact, most of these 2,600 pulsars are within our own galaxy. So that's kind of really
Wow.
interesting to see.